Okay, so today we're looking at Pythagorean theorem, which is a simple concept that is used to solve sides on a right triangle. So if I have a right triangle looking like this, uh now Mr. Pythagoras, he said that, hey, if I want to know the if I want to know the length of the longest side, which is called the hypotenuse, the hypotenuse. If I want to find the longest side of the triangle, all I need to do is to simply, if I just add these sides, I want to give these three sides random names, letters. So C, B. Now, if I could find the, if I can find the sum of the square of both the sides and equate that to the square of the longest side, that can simply help me find the length of the longest side. So the theorem or the formula is a squared plus b squared is equal to c squared. And we're going to simply going to try to find this out. Now, what we're going to basically do before we go into trying to solve the longest side of the triangle is to find out if you have three dimensions, like let's say we have three dimensions. So this is one side, this is another side, this is another side. I want to find out which three dimensions would be appropriate to form a right triangle. In other words, if I were to use a formula, a squared plus b squared is equal to c squared. If I have three dimensions, like let's say I have, let's say I have, let's say 3, 4, and I have 5 right here. That 5 right here is my, right. And I have 5 right here. Let me see this. I have 5 right here. Where is this thing? Give me a minute. Right, I have 5 right here. Now the question is, would these dimensions be used to actually be used to form a right triangle? Now the concept is this: we know what is an equation. An equation is just a mathematical sentence that tells you that the left hand side should be equal to the right hand side. That's just what the equation is. So, for example, if I say 4 plus 1, it should equal to 5. Because if I were to simplify this side, I would get 5, and you have 5 is equal to 5. 5 is only equal to itself and nothing else. So the idea is, if we could get like three sides on each side of a triangle, right? Three dimensions on each side of a triangle. If we should plug them into the formula here, and if we have the left-hand side be equal to the right-hand side, then these dimensions could be used to form a right triangle. Let's use this as we go. Now, the longest side of this triangle is always represented by C, and we could use A or B for any one of the shorter legs. But C is always the longest side. And C is on this side, A and B and A could be anywhere on this side, but C must be on this side. That's the longest side of the triangle. So let's see. We have three dimensions. We have 3, 4, 5. Now let's see if 3, 4, 5 would be three appropriate dimensions to form a right triangle. So let's look at the formula. The formula is a squared plus b squared is equal to c squared. Now what we're going to do is to plug these values into the formula to see if when we simplify this formula with these dimensions being substituted into the formula, if the left-hand side is equal to the right-hand side, then we can conclude that these three dimensions could be used to form a right triangle. So let's look at it. Because remember, the idea is if I were to square this side and square this side and add them, it should be equal to this side square. And let's look at it and see if it makes sense. So we say a square plus b square is equal to c square. What is a square? You could put 3 if you want. What is b square? What is b? You could put 4. And the square, what is c? C is 5, the longer side. Right? So if we should work this out, we got 3 raised to the second power is 9. 4 raised to the second power is 16, and 5 raised to the second power is 25. Let me write this properly. I want this. Right? 25. 16 plus 9 is 25. And 25 is on the side. You're going to see that the left-hand side is equal to the right-hand side. Therefore, these dimensions could be used to form a right triangle. Let's try another one. If I have, let's say I have 8, 6, and 10. How would these 3 dimensions be used to form a right triangle? So all we need to do, the first thing, we draw a triangle, and then we label our sides. Remember that the hypotenuse is the longest side, so we put 10 there. And we could just randomly put 6 and 8 anywhere right there. All we want to prove if these dimensions would be appropriate to form a right triangle. So what do we do? After constructing our triangle and we place the numbers at each dimension, we write our formula. All right, so our formula is a squared plus b squared is equal to c squared. Now we're going to plug the values in. So we could say 8 squared right here. We could say 6 squared right here. And remember, we remember that b, c must always be the longest side. If I were to square 8, I get 64. If I were to square 6, I get 36. If I were to square 10, I would get 100. Now, let me just erase this thing. So I would have about 64 plus 36 is equal to 100. Let's work out the left-hand side to see if it equals the right-hand side. So if you add this, we get 100 on both sides. Therefore, these dimensions, 8, 6, and 10, could be used to form a right triangle. Let's try another one. Let's say we have 3, 4, and let's say 9. Would these dimensions be used to form a right triangle? Let's try it out. The first thing we need to do, we don't have to draw the triangle. We could just do this for visual purpose. So we could say the 9 goes the longest side. 4, you could put 4, or you could put 4 here if you want, since this side seems to be longer than 3. For me, though, it doesn't really matter which side I put it. Let me try. Let me see. Okay, so 3 right here. What's the formula is a squared plus b squared is equal to c squared. All I'm going to do is to plug my values into the form, into this. So I'm going to say, all right, so I'm going to say 8. I'm going to write now 3 squared plus 4 squared is equal to 9 squared. All right, let me get some space right here. So 3 squared plus 4 squared equals 9 squared. We're just proving if these sides are going to be equal. So we have 36 plus what's this? 16 plus 81. And if we should look at this carefully, let's see what we get. When we add 36 plus 16, we get 52. And this side is 81. Therefore, these dimensions could not be used to form a right triangle, because when we plug these values into the formula, when we evaluate both sides, we are not getting the left-hand side being equal to the right-hand side. And there you go. We don't have to do any more of these questions. It's just straightforward as that. Very, very, very clear. So once if you want to prove, if 3 dimensions, right, 3 numbers could be used to form a right triangle, all you need to do is to write your Pythagorean theorem, the a squared plus b squared is equal to c squared. Are you going to take these? You're going to take, let's say I put 9 here, I put 3, and I put 4 here. I'm going to take this, put it where c is, and I put for b, or that for c, for this for b, or that for a. You're going to plug the values in, you're going to work them out, and you're going to see if the left-hand side is equal to the right-hand side. So if the left-hand side is not equal to the right-hand side, then we say it can't work. cannot work. But if after you plug the values into the formula, you evaluate it and you get the left-hand side. If the left-hand side is equal to the right-hand side, then we say it can work. So there you go. We're just proving if 3 dimensions could be used to form a right triangle by using the Pythagorean theorem. Stay tuned for more.